Now, let's remember the six ratios that I mentioned this week. I mentioned sine of theta and then cosecant of theta. I also talked about cosine of theta and secant of theta. I talked about tangent of theta and cotangent of theta. And I said sine was going to be opposite over hypotenuse, and cosecant was going to be the reciprocal. Cosine was going to be adjacent over hypotenuse, and secant was hypotenuse over adjacent, right? The reciprocal. And tangent, I said it was going to be opposite over adjacent, and cotangent was adjacent over opposite. To be honest with you guys, I just extended to the six trigonometric functions because there are six of them. However, in geometry, I'm supposed to focus only on three of them. But I figured you guys could do all six. I want you guys to start getting used to that there are six. In Algebra 2 and Math Analysis, you guys will deal with all six. Not too hard to deal with them. Now, sine, I want you guys to remember opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And there's an acronym that's going to help you guys remember it. We have this thing that we call SOHCAHTOA. Now, what does SOHCAHTOA stands for? Sine, if you read this, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. It's easy to remember those three fractions. And then remember I said secant looks like cosine backwards. Oh, so I know secant goes with cosine. And I also talked about cotangent looks like tangent backwards. Oh, cotangent and tangent go together. Now sine and cosecant, they don't look alike, but they are reciprocals of each other. This little hint is going to help you guys later on in Math Analysis, Algebra 2. So remember SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. So let's take a look at this work right here. I'm asking for sine of theta. Remember I said from the 90 degrees, the one side that is far away, that's the hypotenuse. And then from theta, the one side that is opposite is the one side far away, and this is the adjacent. And then sine, let me remind you guys of SOHCAHTOA. Sine is opposite over hypotenuse. So I'm just going to go 14 over 7 radical 13th. First of all, let me simplify. 14 over 7. Isn't that 2 over 1? So I'm just going to have 2 over radical 13. Right? 14 divided by 7 just gave me a 2. Simplify my whole numbers first. Then, I told you guys we cannot have radicals at the bottom. So, since we have a radical at the bottom, let me multiply top and bottom by radical 13th. So, on the top, we have 2 radical 13th. At the bottom, we have 13th. My whole number is 2 over 13th, nothing I can do. Now, how do you type this? 2 radical 13th over 13. Now, let's take a look at question number 14. I know cosine is adjacent over hypotenuse. Let me label all my sides first. From the 90 degrees, the one that's far away is always the hypotenuse. From theta, the one that is far away is the opposite, and the one that's close to it is adjacent. And I know cosine is adjacent over hypotenuse, so I'm just going to go 7 over 25. Fraction cannot be reduced anymore. I have no radicals at the bottom, so that's good. How am I going to type this? 7 over 25. Let's take a look at tangent. Here's my hypotenuse, here's the opposite, here's the adjacent. And I know tangent is opposite over adjacent, so I'm going to go 12 over 16th. Let me simplify the fraction, right? 12 over 16, we know how to simplify fractions. I'm just going to call this becomes 3 over 4. How do you type this? 3 over 4. And one last example, here we have sine. So here's my hypotenuse. From theta, this is the opposite, this is the adjacent. And I know sine is opposite over hypotenuse. So I have 17 over 13 radical 2. 17 over 13, I cannot simplify. However, I have a radical at the bottom. So let me multiply top and bottom by radical 2. So on the top, I have 17 radical 2. At the bottom, radical 2 times radical 2 becomes 2. 13 times 2 is 26. Look at your whole number. 17 over 26, nothing we can do. So that's simplified. 17 radical 2 over 26. How do I type this? 17 radical 2 over 26. Now, with you guys, this is how I showed you guys the work. I was using theta. It's a Greek letter that is used for measurements, for angles. Now, in geometry, we're not quite supposed to introduce the letter theta yet. We're supposed to label all three sides. What I was supposed to do in this case, let me show you how your work should look like, how it is going to look on your homework. You're not going to have theta. Instead, I'm going to label each corner as A, B, C, or any letters that I want. And then remember how theta was right where angle A is? So instead of a theta there, I'm going to ask for sine of A. So in geometry, we're supposed to label the three corners as, any letters we want, A, B, C, any three letters we want. In this case, I label it as A, B, C. Now I call it sine of A. What that means, since I talked to you guys about theta, what that means is that theta is at corner A. So if you guys just want to write theta, that way you guys that's what you guys are familiar with. The letter I'm going to give you guys, because I'm not going to show you guys theta on the graph, the letter that I give you guys, that's where theta is. So for number 14, if I was to label this side as A, B, C, instead of cosine of theta, I will call this cosine of C. Notice how theta is at C. And then on your homework, I will not give you theta. I will just have the three letters, A, B, C, and I call it cosine of C. That's just the notation. Same thing here. I could label this side as any letters that I want, any order that I want. So if I was to not write theta there, so instead of tangent of theta, I will ask for tangent of C. You are not going to see theta on your homework. I'm going to ask for a letter, tangent of C. Once I said angle C, that's where I had theta. I said any letter. So for number 16, I'm going to call this as D, E, F, just to call it anything. So theta, I will not write theta there. I will not write theta anywhere. So instead of calling this sine of theta, I will call this sine of F. On my notation, sine of F means theta is at F. But once again, on your homework, right now for the review, I did write the letter theta because we are used to it. But for the homework, I'm not going to, because that's how we're going to be using the angles for the next few weeks. So I'm not going to use theta anymore. I'm going to label the corners. And the angle that I use, that's where theta is.